Hi, everybody. It's 2025. I'm recording a new one. I haven't done one in a while. I want to make sure my current classes don't think he's only using old stuff. I was looking through some material and I found something in the book that's really good. And I want to promote the book as well as show you how you can play around with this on your own if you want to. But it's a pretty important point related to sampling distributions, which is what we're doing right now. So as a reminder, the way you go to the book is if you go to Clever. Wait, you guys can't see what I'm doing. I got to share my screen. Let's share the whole screen. Let's not make the mistake I made a minute ago. If you go to Clever and then go to Achieve, eventually it will take you to the ebook. I think there's also a PDF out there that I put out. But this one, you can actually jump right to the page. And there is something, I think it was on page 488, that talks about what we were doing with when we were doing the whole thing with orange candies. And the idea is we could set the number of orange candies that were there and then do sampling. And one of the points that was supposed to come across there, or that should come across there, is on page 489, which I'm going to pull up. And what this picture shows is the one on the left here. If you only had 10% orange candies and you only grab 25 at a time, you are normally going to get about 0.10 because that's what we're expecting, or 2.5 candies. But sometimes it'll be higher and sometimes it'll be lower. And there's a possibility you could actually get a large number, like 24 or 25. It would be unlikely, but it could happen. So this thing has a tail on the right because some of those larger values are unlikely, but they certainly can happen. Whereas it's impossible to go below 0. So this is, I can't go less than 0. And so this is slightly skewed to the right because occasionally I'll get very large values. Definitely skewed. We don't like skewed. We like approximately normal, which is what the one below it is. It's the exact same thing. It's 10% orange candies. It's centered at 0.1 still. But because I bumped it up to 100, this passes our large counts test because 0.1 times 100 is 10. Whereas over here, 0.1 times 225 is 2.5. This fails the large counts test. So once again, our large counts test tells us, if we do a large enough sample size, it will, our sampling distribution, the answers we get will generally be around whatever we're expecting. So in this case, 10%, but will fall off at a normal rate on either side of it, as opposed to being skewed like the top one. Now you notice the middle one here, if I've got a 50% amount of orange candies, it's not a problem. This is still approximately normal because it's kind of in the center and occasionally be higher or lower, but I'm not bumping up against the 0 that I was over here. Now, if I make it 100 down at the bottom here, it's even smoother, but the top one was fine. So 25 would have been fine if we knew our proportion was close to 50%. And then the one on the right here just shows, well, what if we had 90% orange candies? In this case, our center is still 0.9 because that's what we're going to get generally. But occasionally we'll get very small number of orange candies, and I can't go more than 100%. So I'm bumping up against this wall, which is why if I don't get enough, I'll be kind of, how I have a tail on the left side because I'm bumping up against the wall on the right side. But once I go up to 100, I'm fine because the 0.9 was never the problem. 0.9 times 25 is fine. That's going to be like 22 and a half candies. The problem was the failure rate. The number of non-orange candies would only be 10%, and that fails large counts. So this is what it is for proportions. There's a similar thing going on with means, which is what we did in class probably today or yesterday around heights of NBA players. It works with weights. It works with anything where it's a numeric answer and we're not counting out of a total. We're just literally averaging things. So in the book on page, I think 509, there's several pages in chapter 7.3 that has this stuff on it. But they talk about this little widget here, which is pretty easy to find. And I'm just going to walk you through it. The way I found it was I literally went to online stat book sampling distribution. I looked that up. I'll try to put the link out here here. But when I clicked on that, it brought up this thing. And then if I hit begin, it's exactly what the picture in the book is. So this is a normal curve. And what this shows is I'm going to randomly grab 5 things out of this. The center of my mean here is of the normal curve is 16 and my standard deviation is 5. And I'm going to get I'm going to get one sample of 5 things. and it's going to average it. So those 5 things, the average was there. And I can do another 5, 1, 2, 3, 4, 5. It's just randomly picking, and there's another one. And I can do another 5, 1, 2, 3, 4, 5, and it's picking. And then if I wanted to do more, so I'm going to get more and more and more, but most of them are going to be about where my center is. And so let me just do 10,000 of those. And what this shows is, oh, same curve. The center is over here, 15.97. So it's very close to what the mean was up here. So most of my answers are going to be close to the number that I'm trying to infer, my parameter of 16. And most of them are going to be closer than any individual ones. Notice this is smaller. Okay. So, and this will always, now notice the n is equal to 5. If I make the n is equal to 25, so this is going to do 5 at the top, 1, 2, 3, 4, 5, graph it there. And now I think it will do, oh, how to do it down here? Mean 1, 2, 3, 4, 5 at the top, right there. 1, 2, 3, 4. This is going to take a minute. It's grabbing 25 now, and it's going to average it. It's going to land somewhere in there. And it takes a really long time. So I'm going to repeat the top part, which is going to look like the graph we had a minute ago, but notice what's different about this one where I'm grabbing 25 at a time. So let's do 10,000 of those. Okay, top one. And notice there's still this is not quite as normal as it should be. This is looking even closer to normal. And look how much narrower it is. So this is just showing that, oh, as I increase my sample size, my sampling distribution gets smaller, which means in general, my estimates are going to be better. It doesn't, I could still get one that's too high or too low, but I'm less likely. Whereas up here, I'm more likely to get one that's too high or too low. And notice over here, my mean is 16. My standard deviation is 2.26. So I could be off easily. You know, the answer up here is 16. Could easily be between 14 and 18 down here because of my standard deviation of 2. Down here, standard deviation is 1. It's really unlikely for me to get something lower than 15 or more than 17 because my standard deviation is so narrow down here. I can still get a bad sample, but it's not going to be too far off. All right, now here's the really powerful part. This is normal. This is normal. Let's switch to where I've got it skewed. So skewed, my average of this skew, the middle of this thing is 8. I'm going to do 1, 2, 3, 4, 5, just so you can see what's happening. And it's going to put 1 there. Oh, it's doing the bottom one too. 1, 0, 5, 60. And 5, 5, 5. Notice there. Okay. 5, 25. Okay, I'm going to do 5. So you'll notice these are here. These are here. They're kind of about in the same place. Hard to tell the pattern. So I'm going to do 10,000 of those. Grabbing 25 out of here, putting them here, 25 out of here, putting them here. Watch what happens. So this one at the top, it is still somewhat skewed. It's not as skewed as the previous one. It's somewhat skewed. Down here at the bottom, this is not very skewed at all. Okay, it is roughly normal. And this is a really powerful point that even if our population is skewed, and oftentimes we won't know if it's skewed or normal, the sampling distribution will always be normal or approximately normal as long as my sample size is big enough. 5 is probably not big enough. Yeah, it's reasonable. Now notice what the means are here. Up here, mean was 8. Center of this thing is 8. It's right here. Down here, the mean is 8.06. And down at the bottom, it's 8.08. So the means are still correct. The problem is this one has got a lot more variation, which is to be expected because I'm only doing 5. But it's also got some of that skew left over. Whereas when I up it to 25, most of the skew goes away. Still slightly skewed, which is why 30 is usually our magic number in most cases for how many we want to sample when we're doing sampling distribution. All right, I'm going to give you one more thing to try on your own. So I'm going to change this to custom. And the idea here is once you click custom, you can make this thing any shape at all you want to make it some crazy shape. And then my challenge to you is to set the mean n equals 5 and our mean n equals 25. Do like 10,000 of those and see if the same pattern that we had before shows up. And just to show you that it does, I'm going to do 100,000 in each. Notice the middle that I drew, it'll be different for you, but my middle was 16.6. 100,000. pretty close to normal, even though I had this goofy shape up here. Okay. This one, still not quite normal, still a little goofy, and 25 is not quite perfect. In fact, I think by chance this one looks better to me. But both of them have a center very close to what I expect. This one definitely has less variation, and this one should be a little more normal. Okay, I think that's enough. Let me stop sharing. Ciao.